In today's lesson, we are going to be estimating limit values from tables. So keywords, we're looking at tables, which means we are estimating, not finding exact limit values, but estimating. Okay, so here are two different tables. I actually want to do the one on the right first because it's a little bit more obvious. So the limit as x approaches 0 of f of x. So x here, approaching 0 from the left, approaching 0 from the right. 0 is going to be right here. Okay, so now the y, approaching, well, this, pretty obvious, it's a pretty good estimate. These numbers are getting real close to each other, and it's real close to 4.25. Okay, now let's look at this one. Limit as x approaches 3. So I'm going here from the left, approaching 3 from the right. That's not as good of an estimate, but I can still make something work. So let's think about this. So 2.75 to 3.5. I'm going to write this out, 2.75 and 3.5. I'm going to kind of try to zoom into this table a little bit. So 2.75 to 3.5, if I just kind of estimate my x values going up by 0.25, so I'm going to look at, there's 3, and here's 3.25, and then 3.5. So if we're looking here, we want to get to 3. Well, 3 is a lot closer to 2.75 than it is to 3.5. So now if I'm looking at my y values, 3.4 and 4.2, my estimate, I'm going to want closer to 3.4 than I am to 4.2. And now one way to think of this, we could notice how if I'm looking at steps between these, I'm getting to 3 in one step out of these 3 steps. So that's like 1/3 of the change gets me to 3. So what's the change from 3.4 to 4.2? It goes up by 0.8 is the total change. So I want just 1/3 of that change. So what is 1/3 times 8/10? So that's 8/30ths. And that's a change that I need to add to 3.4. So if I add the change to my 3.4, I'm going to get 3.6 repeating. So as I'm approaching 3, this one is approaching 3.6. This is all just an estimation, but you want to try to get the best estimate possible kind of by breaking these numbers down. All right, now we're going to turn a function into a table of values and then estimate it. For some reason, this is not correct. That's supposed to say x squared minus 4 over x minus 2. And we're going to fill out a table as x approaches 2. So what I'm going to do is kind of put 2 in the middle, and I want to get really close to 2. So we could, on the right, 2.001 and 2.1, and then on the left, 1.999 and 1.9. Okay, so now I'm going to get out my calculator and show you a couple tricks on how to get these numbers easily. Okay, so here's my calculator, y equals, I'm going to input that function, x squared minus 4 over x minus 2. I'm going to go to my table settings and take off it on auto and put it on ask for the independent variable and go to my table, and I can just type in my x value is 1.9. I hit 1.99 instead of 999. That's okay though. I get an error for 2, because that would give me 0 in the denominator. So let's write these down. All right, so as x approaches 2 from both sides, y is approaching 4. And just once again, undefined at 2, because 2 minus 2 is 0 in the denominator, which can't happen. All right, here's another one, very similar to what we just did. I've got a function, limit as x approaches -2. So let's put -2 in the middle. Okay, to the right of -2 is -1.999, -1.9. To the left, -2.001, -2.1. All right, I'm gonna get my calculator out and you can see those buttons once more. So once again, in my y equals, get that function in there. X to the third minus 4x squared minus 7x plus 10 over x plus 2. Same thing, table setting. We want to go to ask in the independent one, then my table, and you just get to type them in. All right, let's write them down. Okay, as x approaches -2, the left and the right, it is approaching 21. And once again, it's undefined here because the denominator would be 0 with the x value -2. And here is our last example. Before reading any of this, let's just jump to this quick. And what looks different? I snuck a little cosine in there. So the function f is continuous and increasing for all values x is greater than or equal to 1. The table gives the value of f at selected values of x. Approximate the value of the limit as x approaches 2 of cosine of f of x. So with this one, almost just pretend the cosine's not there for a second. And here's our function f of x. As we approach 2, f of x approaches 5. So now what we're going to do is just evaluate cosine 5. And this is a calculator question, so we can just type it in, cosine 5. You need to make sure you're in radians. And when you get the decimal, I'm going to write the whole decimal down. 0.283662185. Okay, so AP Calc, they want 3 decimal places. 1, 2, 3. You can round or truncate. They will only read the first 3 numbers. So 0.283 is correct. 0.284 is correct. You could go further if you want. Some will give the advice to always go 4 or 5 places, because when they're reading your answer, they're only going to read the first 3. It doesn't matter what you put after that, but if you just go further, it will help you from making a rounding error. If you accidentally put 0.282 for some silly reason, now the whole thing is wrong. So just keep that in mind, truncate or round. So there's your lesson on limit values from tables. Good luck with the lesson.